This is R.D. Sharma Solution Class 12th. Chapter 19 exercise is 19.9. Indefinite integrals we are talking about. Now this integration of log x by x dx. So this exercise is having more than 70 questions. And the previous exercise I told you to target the denominator so that we can get the numerator. Here most of the questions are related to targeting the numerator or otherwise, mixed. So if you take this log x as t, dt by dx will be what? Log x is 1 by x. Now this dx, if we take on the right hand side, it will be dx by x. So this dx by x, we are getting it as dt. So integral will be formed like this. So this is dx by x is dt and log x we have taken as t. So this will be t dt. And what is the integration of x raised n? X raised n plus 1 by n plus 1. So this is not x, actually it's x raised n plus 1, x dx. So this is t square by 2 plus constant of integration. What is t here? Log x. So log x whole square divided by 2 plus constant of integration, and this is your final result. So this is how you are going to solve it. The words like let, now, all these has to be written. Now here also, if you see, we have log 1 plus 1 by x. And if we equate it to t, we are going to get the denominator. How? So let us take this t equals to log 1 plus 1 by x. When we differentiate this, dt by dx is going to be 1 by 1 plus x, first thing. And the differentiation of 1 plus 1 by x. So 1 will be 0 and 1 by x is negative 1 by x square. 1 plus 1 by x will be what? See, it will be x plus 1 by x, and this is in the denominator. When it will go to the numerator, it will be x by 1 plus x multiplied by negative 1 by x square. So one of the x will get cancelled. So this goes x by x plus 1 as I just suggested, and then we have this negative 1 by x square. 1x you can cancel. This will be negative, I am taking it on the left hand side, and negative dt is going to be equal to this 1 by x, 1 plus x, and of course dx is in the numerator. Now what do you get here? This whole dx by x 1 plus x is negative dt. So this is how it has become simplified now. So this integration will become integration of log 1 plus 1 by x was taken as t, and this is whole is negative dt. So negative you can take it out and this will be dt. So t dt will be t square by 2 plus constant of integration. What was t? It's log 1 plus 1 by x. So just replace t by log 1 plus 1 by x. Log 1 plus 1 by x. This is whole square of this one. And don't write 2 if a term is bigger like this. Just multiply half with it. It's equivalent. Plus constant of integration. This is your final result. So this is the result in the printed form. If somebody wants to write it, where let should be put, all these symbols now, the integral sign, the dx should not be forgotten. So this one also is almost similar. See, 1 plus root x, if you take this as t, you are going to get this dx by under root x with an additional number or stuff or content. Dt by dx will be 1 by twice of under root x. So this 2 dt is going to be equal to dx by under root x. So this dx by under root x is 2 dt. So this integral will become 1 plus under root x is of course t. So it will be t square. I am taking 2 dt. So 2 I am taking outside. So it will be t square dt. So actually let me replace this by t square now. So let me write it again. 2 integration of t square dt. And what will be the x raised n integration? X raised n plus 1 divided by n plus 1. So t raised 2 plus 1 3 by 3. So this is 2 by 3. T cube, in place of t cube take 1 plus root x, and this is whole cube plus constant of integration. Now the question you would ask is why 1 plus root x is not cubed? Why it was not been expanded? Actually, when the things are expanded and when we make it smaller and we try to say make it or print it in a terms which are lower than the initial expression, then it is called simplification. Okay, so we don't do 1 plus root x into 3 times and write it here. This is self-sufficient and this is simplified version. So this is the result. So as I told you, the initial questions are easier. There will be typical in the coming questions. There are 70 plus questions. So if you take this 1 plus e raised x, if you put it as t, you are going to get ex. because differentiation and integration of e raised x remains same. So the question you will ask me, why haven't you taken under root t? Please remember, the question is saying solve. That is, there is a difficult situation and you have to solve this equation. So it's a kind of puzzle, say some problem, or the, an event is given to you. You have to solve it and make it happen. So that is how, if you put under root t, you will have to put more effort. So in order to resolve your effort, just put t equals to 1 plus e raised x. dt by dx will be e raised x, and dx you can take on the right hand side. E raised x dx will be dt. So this is going to under root t. So now under root t is easily integrable. That's why we are in a safe position to solve it. What is under root t? 1 by twice under root t was a differentiation, if you remember. But here the t can be written as t to the power half. Anything root is actually to the power 1 by that thing. So x to the power n by n plus 1 by n plus 1, x to the t to the power 3 by 2 by 3 by 2, and 3 by 2 in the denominator goes up to 2 by 3, so 2 by 3 t to the power 3 by 2 plus constant of integration. What is t? T was 1 plus e raised x. So 2 by 3, 1 plus e raised x to the power 3 by 2, this one, plus constant of integration. So this was quite easy now. So this is the result which you can use to write actually how it has to be done. Now this is cube root of cos square x sin x. So if we take this cos x equals to t, sin x will come, and that's what we want. Always remember, the thing which is inside under root should be taken first, and then to see whether we get something out of it or not. So dt by dx is minus sin x, negative dt. I have taken negative on the other side. It's sin x dx. So sin x dx can be written as negative dt. So negative dt and integration of third root of under root cos square x will become cube root of cos square x third root of t square. Now this, anything like the root, third root or fifth root, it is nothing but, if it is on the x, it's x raised 1 by 3 and x raised 1 by 5. So this t square was already there. Now 1 by 3, so 2 by 1 into 1 by 3 gives 2 by 3. So t to the power 2 by 3 it is. So integration will be equal to integration of t raised 2 by 3. In place of sin x dx, just put negative dt. The negative come outside. It will be t raised 2 by 3 plus 1 divided by 2 by 3 plus 1. And this is negative. So this will be negative. Now replace t by cos x. See, 2 by 3 plus 1 is simply 5 by 3. It goes up, it will become 3 by 5. And this also is 5 by 3. So t to the power 5 by 3 divided by, and this what divided by was now has become 3 by 5 plus constant of integration. So minus 3 by 5. Now replace t by cos x. Cos x to the power 5 by 3 plus constant of integration. This is your result. So this is what we have discussed. Okay. So if you just give a bit, cos x is equal to sin x differential. Now this question, 1 plus e raised x seems to be a good candidate to be replaced or equated to t, and then we differentiate. So there are different ways you can do. E raised x you can put it as t, or 1 plus e raised x you can put it as t. 1 plus e raised x will be better. When you differentiate this, 1 is going to eliminate anyway. So 1 plus e raised x will be a better choice. So this 1 plus e raised x, if we place it as t, this dt by dx will be simply e raised x. So dt will be equal to e raised x dx. So this numerator is as directly as we got. So this will be equal to integration of e raised dx is dt divided by t square, and this will be simply t raised minus 2 when it goes up. So it will be t raised minus 2 plus 1 divided by minus 2 plus 1, and this plus constant of integration will come. This minus 2 plus 1 will give you negative. So negative t raised minus 1. So this will be minus 1 by t plus constant of integration minus 1 by t. T is 1 plus e raised x plus constant of integration. This is your answer. Now next one is cot cube x cosec square x. Now we know that the cot x will directly give you cosec x, cosec square x actually. And similarly with sec and tan also, when a question of sec and tan will come, same thing you have to do. So when you place this t as cot x, dt by dx will be equal to minus cosec square x. If you just take this negative on one side, it will be negative dt equal to cosec square x dx. So this whole term which we are talking about is negative dt. So this integration will be equal to cot cube is t cube, and this cosec square x dx, negative will go there, it will be dt. So this is t raised 3 plus 1 divided by 3 plus 1 plus constant of integration. So this negative t to the power 4 divided by 4, negative 1 by 4 we can take outside, t raised 4 will come. What was t? It was cot x. So negative 1 by 4 cot x to the power 4 or cot 4x, it's same thing. You can write it as like this also. And then the constant of integration. So this you can do by yourself. It's quite easy and similar with the tan and sec squares x like this question. Now in this question, sine inverse x differentiation is directly 1 by under root 1 minus x square. This is the background knowledge with which we will start. So t will be equal to e raised sine inverse x. When we differentiate this, dt by dx will give you e raised sine inverse x will be what? E raised of anything will be e raised of that thing only. So it will be e raised sine inverse x, and then we will differentiate this sine inverse x. It will be 1 by under root 1 minus x square. So it will be under root 1 minus x square. Now this dx can go on the right hand side. So the whole right one is the result. So this e sine inverse x whole square, because it was t being taken. So this is simply e raised sine inverse x into e raised sine inverse x. You can write it as square means, x square can be written as x into x. So e sine inverse x into e sine inverse x, and one of the part will divide by under root 1 minus x square, which is our question also. Now this whole on the right is simply dt. We have just done it. That is, e raised sine inverse x was t. The second term, all of it remaining after e sine inverse x is dt. So now it's t square by 2. What was t? T is e sine inverse x. So e raised sine inverse x whole square by 2, or you can multiply it by half in the front plus constant of integration. So this will be your final result. Now we have 1 plus sine x divided by under root x minus cos x. Now if you witness this denominator, it can easily produce the numerator if differentiated. So if you take this t equals to x minus cos x, dt by dx will be equal to 1 minus cos x is minus x, so minus minus plus 1 plus sine x. That's what you have in the numerator. So dt will be equal to 1 plus sine x into dx. So what do you get from here? 1 plus sine x into dx is dt. The basic thing is to get the numerator from the denominator, or from denominator we can get the numerator, otherwise vice versa. So here we have taken the denominator, got the numerator. Previous questions it was vice versa. So this will be under root t, 1 plus sine x dx is dt. Under root t is simply t raised half, and since it is in the denominator, it goes up, it will be t raised minus 2. So t raised minus half, minus 1 by 2, sorry. So t raised minus 1 by 2, it will be t raised minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus constant of integration. 1 minus half is half only. So numerator will be t raised half, denominator is half, so that goes up, it will be twice of t raised half is of course under root t. So 1 by 2 is 2, and t raised half is under root t. So what do you get? 2 under root t. T was x minus cos x. You can write it as x minus cos x plus constant of integration. This is your final result. So this is how we are going to go about it. All this English like language now you have to do while writing. So e raised sine inverse x, that question we have done, and this question is almost similar to that one only, because it is direct. Sine inverse x differentiation will give you 1 by under root 1 minus x square, that you already know. So t is equal to sine inverse x. dt by dx will be equal to, what is the differentiation? 1 by under root 1 minus x square. Dx goes on the right hand side, dt will be equal to dx by under root 1 minus x square. So this is what we have in the numerator and a part of denominator as well. So dx by under root 1 minus x square, we directly got dt here. So this integration will be integration of dt, because it's there. Sin inverse x we have taken as t, so it will be t square. Now this t square goes up, it will be t raised minus 2 dt. So x raised n integration is x raised n plus 1 divided by n plus 1. So integration of x raised n will go like this. This is a standard result which I am showing that you can use directly. So here it will be t raised minus 2 plus 1 divided by negative 2 plus 1, and with a constant of integration. So t raised minus 2 plus 1 is t raised minus 1. In the denominator 1 minus 2 is negative 1. So sin inverse x we have taken it as t, so now I'm replacing it to the original. X raised minus 1 is 1 by x, so sine inverse x to the power minus 1 is 1 by sine inverse x. Negative is already there, constant of integration you have to add. Okay, this one is the result, the printed material for you, so that you can go about it, solve if you want to do it by yourself in the later revision, etc. Now this cot x divided by under root sine x. Now there is one more question coming which is exactly like this, so you have to understand it very well. Now if you take this sin x as some t, you won't get cot x. If you take cot x, you won't get sin x, because cosec x will give you cot x and sin x will give you only cos x. So how do we do it? See, this cot x is cos x by sin x. If you multiply this sin x with writing sin under root sin x as sin x to the power half, the denominator power can be added. See, cot x is cos x by sin x and under root sin x is sin x to the power half. So 1 plus half is 3 by 2. Cos x divided by sin x to the power 3 by 2. So this is sin x equals to t. When you differentiate this, dt by dx is equal to cos x. So dt will become cos x dx. Okay, now you see, if you integrate here, because I just simplified it, in order to get something which we can be, we are able to differentiate it. But here if you see, cos x dx is already there, dt. And denominator it is sin x to the power 3 by 2, so just take t as sin x or t to the power 3 by 2. T goes up, the power becomes negative 3 by 2 dt. Now x to the power n plus 1 divided by n plus 1 we are going to apply here. T raised minus 3 by 2 plus 1 divided by negative 3 by 2 plus 1. 1 minus 3 by 2 is 2 minus 3 by 2, that is negative half. So you get a negative half here. So the denominator it is negative half, when it goes up it will be 2 with a negative sign. So this is negative and 2. So 2 goes up. How about this t raised minus 3 by 2 plus 1? 1 minus 3 by 2 is of course t raised minus half. So x to the power minus half is 1 by x to the power half, and x to the power half or anything to the power half is root only. So 2 divided by under root t. Negative, don't forget about negative. This t goes down with a root. So negative 2 divided by under root t plus constant of integration will come. What was t? Sin x. Let us replace it here only. So under root sin x plus constant of integration. Alright. So this is the result I was talking about. All this is what you have to write actually. So as I was indicating that the previous question and this question is almost similar. So the cos x cannot produce tan x cannot produce cos x, tan x can produce sec or sec tan n, cos x can produce sine. So that is a problem here. But the whole idea is to solve it. The previous question, it was cot x divided by under root sin x, if you remember. This question is tan x divided by under root cos x. So this tan x I am writing it as sin x by cos x. Under root cos x we are writing it as cos x to the power half. So cos to the power 1x and cos to the power half x. 1 plus half gets added, it will be 3 by 2, similar to the previous question. So cos x equals to t, dt by dx will give you minus sin x. Cos x differentiation is negative sin x. So when this goes up, this dx goes on the right hand side, negative can be taken on the left hand side. So negative dt sin x dx. Now if you differentiate here only, that is sin x divided by cos x to the power 3 by 2, sin x dx is the numerator and cos x can be replaced as t. So this integration will be, negative comes outside, dt is already there, and this cos x was t. So under root t will form as the previous question. If you remember, see, it's t to the power 3 by 2 actually. No, there is a slight mistake. I'll just cancel it out. Sin x, cos x was 3 by 2 as in the previous question. So I'll just change this. So I'll just need to eliminate all this. T raised 3 by 2 will go up and it will form t raised negative 3 by 2. So when this t raised negative 3 by 2 will come, it's almost similar to the previous question because it's just x to the power kind of negative sum 1 by n or p by q form. So t raised minus 3 by 2, negative is already there, dt. So t raised minus 3 by 2 plus 1 divided by negative 3 by 2 plus 1. This is with a constant of integration along with added negative sign in front. So 1 minus 3 by 2 is, see this, you can just cancel this negative because see 1 minus 3 by 2 was what? It was negative half. 2 goes up. It was negative 20 gets cancelled. Under root t is in the denominator now. So this negative was cancelled. In the previous question it was negative. Here it is not negative. So this was cos x. T was cos x. This is your final result. So this is the way, if you understand the previous question, this will be very easy for you. Cos cube x divided by under root sin x. So sin x can give you cos x can give you sin x. But it is always advisable that take t when it is under root. Because if you take this say cos x as t, you might get something which is actually in the denominator. You won't get anything, right? Because you need dt or dx as some form of dt which is already in the numerator. So if you take t as sin x, dt by dx will be what? Sin x is cos x differentiation. Dt will give you cos x dx. So this will become integration of cos square x. I am writing cos cube x as cos square x into cos x dx. Denominator here under root, you can write it as t or under root sin x. Why I have written like this is cos x dx is already with us, it is already dt. Cos square x can be written as 1 minus sin square x. 1 minus sin square x, because we have taken t as sin x. So that is why the 1 minus sin square x will form as 1 minus t square, 1 minus t square. Cos x dx can be written as dt. Under root sin x can be written as under root t. Now you got the idea, right? That's why we did cos cube x as cos square x into cos x. So 1 minus t square, for sin we write t. Cos x dx will be dt. Denominator it will be under root, sin x will be t. And we need to just separate them out. So 1 by under root t, that is a separate integration, minus t square by under root t will have a separate term. So 1 by under root t will be what? Under root t is t raised half. When it goes up, it will be t raised minus half. And this is t square and under root t. T square is upstairs. T raised half will go up. It will be t raised minus half. 2 minus half is 4 minus 1 by 2. That is 3 by 2 you'll get. So 3 by 2. So t raised 3 by 2 dt. And when you get this, t raised minus half plus 1 divided by minus half plus 1. And this is negative. T raised 3 by 2 plus 1 divided by 3 by 2 plus 1. Plus constant of integration, of course. So t raised 1 minus half is half only. So t raised half, it is under root t. In the denominator, 1 minus half is half only. So it goes up and forms a 2 in front of under root t. So 2 under root t is the solution for the first term. How about the second term? 3 by 2 plus 1 is 5 by 2. It goes up, it will form 2 by 5. Then we have sin x to the power of 5 by 2 plus constant of integration. Now just replace this sin x by t, this t by sin x, and that is your final result. 2 under root sin x minus 2 by 5 sin x to the power 5 by 2 plus constant of integration is your final result. The main key is writing cos cube x as cos square x into cos x. Then you can take sin x and then you will get the numerator as the cos x dx. This is the whole idea about this question. Okay, this is the way. Next question is almost similar to this one. See, if you are well versed with the previous question, you can just go forward. But here sin cube x, you directly know that we have to write it as sin square x into sin x dx. What is the denominator? Under root cos x. So this cos x has to be written as t. dt by dx will give you what? Cos x is minus sin x. So negative can be brought along with dt. Dx can be taken to sin x as the cross multiplication. Negative dt is sin x dx. So this sin x dx is negative dt. This negative goes outside. Dt will remain there. Sin square x, you cannot write. There is nothing. We can have cos x equals to t. So sin square x can be written as 1 minus cos square x. Now you can put t. So 1 minus t square dt, denominator of course under root t. So negative dt is there. So just put this negative in front. Okay, this minus we will deal later. I'll just swap the places of the term and that will accommodate the negative sign. So just separate these two terms, 1 by under root t dt minus integration of t square by under root t. So t raised minus half, under root t of course goes up and forms t raised minus half. And here you have t square by under root t. This is 2 minus 1 by 2 because under root t is t raised half, it goes up. 2 minus half is 3 by 2. So t raised 3 by 2. So let us, this negative sign as I told you that we will just use it. T by 3, t3 by 2 dt. This is t raised minus half. So t raised minus half integration here with a dt. So this will form t raised 3 by 2 plus 1 by 3 by 2 plus 1 minus t raised minus half plus 1 by minus half plus 1 plus constant of integration of course. So this t raised 3 by 2 plus 1 is t raised 5 by 2, denominator 5 by 2, it goes up, 2 by 5 will be the result, and minus t raised 1 minus half is half only. So t raised half it will be under root t only. 1 minus half is half, the half goes up and in the inverted form it will form 2. So this final answer replacing t with cos x is 2 by 5 cos x divided by 5 by 2 minus 2 under root t. This t will be cos x. So under root cos x plus constant of integration. This is your final result. So this is what we were talking about. So you can do this. Okay, this question we have already done just now. Now this question is quite you can say very open, very easy. Because tan inverse x directly gives you 1 by 1 plus x square. So just take this tan inverse x as t. T is equal to tan inverse dt by dx will be equal to 1 by 1 plus x square dx. Dx goes here. Dt will be dx by 1 plus x square. That is the final result. This whole is your final result. So this integration will be 1 by dx by 1 plus x square is dt. Under root tan inverse x will give you under root t. So 2 under root t. I can directly tell you because multiple questions we have done. You can just close your eyes and write 2 under root t. You know how just 2 under root t has come. Okay. So this t was tan inverse x. Now just replace t by tan inverse x. It will be twice of under root tan inverse x plus constant of integration. So just 2 steps we used. Okay. This is the result. And see, if you are following me, there are certain tricks and tips which I give you normally to solve this, because it's not always that this question will come, but this sort of question will come that will make your life easier. Now you see here, now sin x is there, cos x is there, sin x cos x is there. If you multiply 2, sin 2x will be formed. Under root tan x, how can we get this sin x cos x along with tan x? What do we put? So there is a way to go. Just a simple trick will make cos x as sec square x or tan x as sec square x. That's what we want, because we need the standard result so that we can integrate it. So under root tan x, just keep it like this. Sin x is there. Now divided by cos square. When you divided it with cos square, you have to multiply this cos with cos, or you can say multiplying denominator by cos. Numerator and denominator of the denominator. So under root tan x is there, sin x cos x will form tan x, and this will be sec square x when it goes up, because it is cos square x in the denominator. When it goes up, it will be sec square x. And now we have come to a solution. We have resolved it. Under root tan x, denominator is tan x. So if you put this tan x equals to t, you are going to get this sec square dx, which is coming from the cos square x from the denominator, which has eventually come when we multiplied cos x numerator denominator of the denominator. So this dt by dx will give you sec square x. This dt will give you sec square x dx. So this sec square x dx is dt, and this tan x, of course, when we took this tan x as t, under root t divided by t. So t raised half, denominator is t raised 1, t raised 1 goes up, it will be t raised minus 1, half minus 1 is t raised minus half. So t raised minus half you got. So let me write it directly. It becomes t raised minus half. Tan x you can write it as t, and sec square x dx we directly received when we differentiated tan x. So you can write this as dt. So it will be t raised minus half plus 1 divided by minus half plus 1 plus constant of integration. 1 minus half is half. So t raised half divided by half, the half of the denominator goes up and it will form 2. So t raised half under root t only. T raised half is under root t. So what was t? Tan x. So 2 twice of under root tan x plus constant of integration is the result. So this trick of multiplying numerator and denominator of the denominator by cos x will make this question happen. Otherwise it will be very difficult. So this is the result I was talking about. Only here if you are able to do it, other things are very rudimentary or trivial. Now this log x will give you 1 by x directly. So there is I think most of you won't need any discussion on this, because just log x will give you 1 by x. Just take t equals to log x. This dt by dx will give you 1 by x dx. Dx will go on the right, dt will be dx by x. So this dx by x is this one from here to here, and that will form integration of dt, this t square, log x was t square. So t square will be t raised 2 plus 1 divided by 2 plus 1, t raised 3 by 3. So t raised 3 by 3 plus constant of integration. T was log x. So just write it as log x whole cube divided by 3 plus constant of integration. This is the final result. Okay, this is a very straightforward question. I hope you'll be able to do this. Now we have this sin raised 5x cos x dx. Now if you take this sin x as t, that is t equals to sin x, what are you going to get? You are going to get cos x. So dt by dx will be cos x. This dt will be cos x dx. And this dt, when it becomes cos x dx, you see what is in the second term? Cos x dx. So integration will be this sin x to the power 5, that is t raised 5. Cos x dx will be dt. Now this x raised n, when you integrate this x raised n dx, it will be x raised n plus 1 divided by n plus 1 without the integration sign. There is integration sign. So t raised 6 by 6. So this will be along with the constant of integration. T will replace by sin x now. It will be sin x to the power 6. And this is 1 by 6 plus constant of integration. This is your final result. Now this is the result, and this is how you are going to write about it. 10 raised 3 by 2 x sec square x dx. Now when you take 10x equals to t, you will directly get sec square x dx. So t will be equal to 10x that we are going to put. dt by dx will be sec square x. dx will go on the right hand side. This dt will become sec square x dx. Now we have a dt here, this one sec square x dx. So this integration will become 10 raised 3 by 2, that is t to the power 3 by 2, and sec square x dx can be directly written as dt. So t raised 3 by 2 dt it will be. So when you use the integration here, t raised 3 by 2 plus 1 divided by 3 by 2 plus 1. 3 by 2 plus 1 will be 5 by 2. 3 plus 2 by 2 is 5 by 2. So we will get t raised 5 by 2 divided by 5 by 2. 5 by 2 when it goes up, it will be 2 by 5. So this is 2 by 5, and now replace t by 10x. So 10x to the power 5 by 2 and plus constant of integration. This is your result. And how we are going to write about it? This is the way you are going to write it. Okay, 10x, if you know that the differentiation of 10x is sec square x, this will be quite easy. That's why the limit is taught first, then the differentiation, then the integration. X cube divided by x square plus 1 whole cube. Now if you remember, we have done a question for cos cube x and sin cube x. So this integration will be x cube can be written as x square into x dx. What will be the benefit of this? You will just know. X square plus 1 whole cube. Now if you put x square equals to t, dt by dx will be equal to 2x. Differentiation of x square will be 2x. This dt will be equal to x dx. If you take this 2 on the left hand side, it will be dt by 2 x dx. Integration will be, now replace x square by t wherever it is. The denominator was t plus 1 whole cube will become this one, and x dx can be transformed to dt by 2, half you can take in the front. Now what will be the next step? Because still we are caught up. T by t plus 1 whole cube, t plus 1 whole cube if you expand it, this will create more trouble in solving this kind of question. So we have to do one more substitution. So this is the first question of multiple substitution. Alright, that is t plus 1 has to be kept something so that we get t in that term. Most of the books, if you see, they will again put t. So that will not solve the issue. You have to take some other variable which is not here. For example, I am taking y. So t plus 1 equals to y is another thing. This dy by dt, when you differentiate, it will be d by dt of t and d by dt of 1. So dy will be equal to dt. So this integration I will be half of integration t plus 1 is y only, but t will be y minus 1. So you can replace t by y minus 1. In the denominator you have x square plus 1 whole cube. And if you remember, it was t plus 1 whole cube and t was taken in terms of y. So this will come. Okay, what is half will deal just now. Let's separate these two terms, y by y cube and 1 by y cube dy. So y by y cube will be equal to this 1 by y square, y minus 2 will come, and that will be differentiated. 1 by y cube will be y raised minus 3 integration dy. So y raised minus 2 plus 1 divided by negative 2 plus 1 and minus y raised minus 3 plus 1 divided by negative 3 plus 1 plus constant of integration. Okay, minus 2 plus 1 will be negative 1. Negative 3 plus 1 is negative 2. So y raised minus 1 will become 1 by y. Here it is negative 3 plus 1 and minus will become plus and 2 in the denominator. So 1 by 2. Y raised minus 2, y will go in the denominator. It will be 1 by y square. This along with the constant of integration, this is integration. But y was taken as t plus 1. Y was t plus 1. First replace y by t plus 1. So negative 1 by t plus 1 plus half 1 by t plus 1 whole square plus constant of integration. Now t is x square. That is the first substitution also has to be done. So wherever you get t, replace it by x square as I am doing it in front of you. Now this half is already there outside. If you remember, I told you half I'll take just now. So this 1 by 2 will deal and we'll take 1 by x square plus 1 outside these two terms and then take the LCM, and that will be a final answer. Now let me show you this half I was talking about, and the integration will be negative 1 by x square plus 1 by twice of x square plus 1 whole square, and I am quite sure that you will be able to do it. Just take 1 by 1 plus x square outside. The final result will be negative 1 by 4, and the only way of doing it algebraically is I would encourage you to do this by yourself. So this is your final result, plus constant of integration, of course. So how it will be done? This is the whole way you have done. So I have interpreted this question myself and solved it in a different way. You can follow some other way. 4x plus 2 into under root x square plus x plus 1 into dx. Now this x square plus x plus 1, if you take it as t is x square plus x plus 1. When you differentiate this, dt by dx will be equal to 2x plus 1. Now there is no 2x plus 1. What to do now? 4x plus 2, you can take 2 common from here. You get 2x plus 1, and this 2x plus 1, when we start integrating, this 2 you can take it outside. 2x plus 1 remains inside. Under root of t will come. Not now, because otherwise 2x plus 1 has to be combined with dx, and then dt will be written. So let's do it in this second step. 2x plus 1 into dx can directly be written as dt, and under root x square plus x plus 1, because we have taken this as t, 2 is outside, 2 under root t dt. The integration of under root t is t to the power half. So you are integrating t raised half. This is dt here. It will be half plus 1, 3 by 2. 2 by 3, this goes up, it will form 4 by 3. So 4 by 3, t raised 3 by 2 plus constant of integration. And t was originally x square plus x plus 1. So when you have this, you can just add a constant of integration also with a power of 3 by 2 in the t term which we replaced. So this is how we are going to go about it. The only thing is, if you place x square plus x plus 1, 2x plus 1 will come and 2 has to be taken out. Now on the background of the question we just seen, 2x square plus 3x plus 1, this is a ditto copy of the previous one. 2x square plus 3x plus 1. If you equate it with t, dt by dx is going to give you what? 4x plus 3. I'm differentiating it. dx goes on the right hand side, so it will form dt equals to 4x plus 3 into dx. So whole numerator is going to be dt. This will become dt divided by under root of t. Under root t is t raised half. When it goes up, it will be t raised minus half. So the final result will be t raised minus half plus 1 divided by minus half plus 1. That you already know. Alright. So this is negative half plus 1 plus constant of integration divided by 2. Divided by 1 minus half is half, so 2 goes up. 2 under root t plus constant of integration. So this is 2 under root 2x square plus 3x plus 1 plus c, because I have replaced t now. So this is the result I was talking about. These previous question and this question are almost same. 1 by 1 plus under root x. Now how are we going to go about it? The first thing will come into mind is multiply 1 minus root x, numerator denominator. Let's rationalize it. But the scenario which will be after cannot be handled in the way we want to. So how are we going to go about it? See, we have under root x and under root x as the numerator denominator. Let's multiply this with the whole term. Numerator will be root x, denominator will be root x into 1 plus root x. Don't multiply it. Okay? If you multiply it, you will get root x into x, and that will not solve our purpose. That is why I am cancelling it. So 1 plus root x will be t. dt by dx will be equal to 1 by twice under root x. When this 2 goes up on the left, dx goes on the up on the right. So dx by under root x will be twice of dt. So this dx by under root x can be written as twice of dt. So this integration will be 2. I'm just saying that 2 can be taken outside, dt divided by what will come? T equals to 1 plus root x. How do we write root x? 1 you can take on the left hand side, so root x will be t minus 1. This root x will be t minus 1, and this will give you t minus 1 divided by t. 2 will deal later. Let us separate these two terms, t by t minus 1 by t, and t by t of course will be only t because dt integration is t, and 1 by t is log modulus of t plus c. Now all of these will be multiplied by 2. Please remember. 2 was already there. Now multiply this whole term by 2. When you multiply this 2 into 1 plus root x, I am replacing t by 1 plus root x now. 2 into log 1 plus root x plus constant of integration. Now if this is the answer, no. It will be 2 root x because 2 into 1 plus root x is 2 root x into plus 2. Now 2 root x you can keep, but this 2 will go along with the constant of integration in order to form another constant. So 2 root x only remain from the first term. The second term will be as it is, 2 of log 1 plus root x. So this is what I was talking about. There are different ways to do it. This is the one approach which I followed. Now this is a very straightforward question. Just a tick or trip is cos square x. If somebody knows, if it is kept as t, you will get the sin 2x as it is. When you differentiate this t taken as cos square x, it will be 2 cos x. Cos x will be minus sin x. So this 2 cos x sin x or 2 sin x cos x will be sin 2x. So this negative dt, because negative goes on the left hand side, will be sin 2x into dx. And that is exactly what is there in the numerator, where there is no denominator, but still the second term you can call it as. So minus will come here, minus dt, and this sin 2x dx is negative dt, only e cos square x. Cos square x was taken as t, so e raised t. And there is only one solution for anything of e raised t integration. It will be e raised t only. E raised t. So this is negative plus constant of integration. This is not cos x, okay? I am just writing constant of integration. So negative e raised cos square x, I am replacing t by cos square x now. This was constant of integration. So this is your final result. Alright, negative e cos square x plus constant of integration. So this is the result I was talking about. Let on differentiating both sides, this you have to definitely write. 1 plus cos x divided by x plus sin x whole cube. Now this, if we take t as x plus sin x, dt by dx will give you whatever is in the numerator you get. 1 plus cos x, dx goes on the right hand side. And this 1 plus cos x into dx will be dt. So we can write this integration as a dt divided by x plus sin x, which is t whole cube. So t raised minus 3 it will be. When you integrate this, this is going to be t raised minus 3 plus 1 divided by negative 3 plus 1. It will be t raised negative minus 2, minus 3 plus 1 is 2 only. So minus 1 by 2, t goes in the denominator. Negative 1 by 2 t square, negative 1 by 2 t can be x plus sin x whole square. So I'm just doing it quickly because this question has already been attempted. So x plus sin x whole square plus constant of integration is your result, final result. So this is how we are going to solve it. Write it. Cos x minus sin x divided by 1 plus sin 2x. Now we have sin x and cos x, we have 1 also. So this 1 can be written as sin square theta plus cos square theta. And this sin 2x can be written as 2 sin x cos x. We can get sin x plus cos x whole square in the denominator, and when we take sin x plus cos x as t, we are going to get cos x minus sin x of the numerator. Okay, let me resolve it. What just I said, let me write it. Cos x minus sin x, in place of 1, I am saying write it in terms of cos and sin. So sin square theta plus cos square theta in place of 1. Then we have sin 2x. This can be written as 2 sin x cos x. What will be the benefit? The cos x minus sin x, the denominator will be a squared plus b squared plus 2ab. So this will be a plus b whole square. So cos x minus sin x remains like this. Denominator will become cos x plus sin x whole square. Now when you take this cos x plus sin x equals to t, the numerator will come by itself. That is, if you take t equals to cos x plus sin x and do dt by dx, this will be minus sin x will be cos x. So it's actually equal to cos x minus sin x only. You can take this dx on other side. This will be cos x minus sin x into dx. So this dt of the numerator, integration this will be dt and divided by t square. Cos x plus sin x is t only. So t minus 2 will go up, that is t square is t raised minus 2, and the integration of this will be t raised minus 2 plus 1 divided by negative 2 plus 1. So t raised minus 1 by minus 1, this will be negative 1 by t after integration plus constant of integration, that is, so you can directly write it as negative 1 by t. What was t? Initially cos x plus sin x. So sin x plus cos x you can write 1 by sin x plus cos x plus constant of integration. So this is the result I was talking about. Please do remember to write this English, let, differentiate, etc. Now here sin 2x divided by a plus b cos 2x. So don't worry about a and b here. When you place this a plus b cos 2x directly equals to t, you will get this sin 2x. How? If you just take cos 2x equals to t, there will be a problem. You will end up with 1 by a plus bt. So again you have to differentiate. That is one more level of differentiation will be there. So it's better to take a plus b cos 2x as t. dt by dx will be equal to, now differentiate both the sides. So it will be b into sin 2x with negative sign and 2. Differentiation of 2x will be 2. So it will be dt negative 1 by 2b I am bringing on left hand side. Sin 2x dx will remain on the right hand side. Now this sin 2x dx is already in the numerator. So this integration will become negative 1 by 2b I am bringing in front of integration sign. Sin 2x dx will be dt divided by t square. What is the differentiation of, integration of t square? T raised minus 2. T raised minus 2 plus 1 divided by negative 2 plus 1. So this will be t raised minus 1 divided by negative 1. So negative you can bring it here. Negative 1 by t plus constant of integration. This is whole integration. So let me write it directly. Negative 1 by 2b will be there. Negative 1 by t will be negative 1 by t. T is a plus b cos 2x. A plus b cos 2x, this whole plus constant of integration. Negative will form positive. So this will be 1 by 2b a plus b cos 2x plus constant of integration. So this is the question I was talking about. Please don't write or make cos 2x equals to t. Okay, you can take a plus b cos 2x directly as t, then you'll get all other things. Now log x square by x dx. Here this x square, if you take x square as t, we'll get 2x as differentiation, but that will only make x dx, but there is no x dx here. X is in the denominator. For that, see, you have to use the log relationship. Log a raised b is b log a. These b's come in front. Here also this 2 will come in front of this log x. So this 2 bring in front log x divided by x. Now this integration will become, now you can take this log x equals to t. So when t is equal to log x, dt by dx will be equal to 1 by x. So dt will be dx by x. Now you have dx by x here, and this dx by x, and 2 you can take it outside. Log x you have taken is as t. Dx by x is t. So t dt is simply t square by 2. There is already a 2, so you can just cancel them out. So it will be just t square plus constant of integration. And what is the t? T was initially taken as log x. So log x whole square plus c is your answer. Okay, this is the way you are going to do it. The only thing is log property has to be taken care. Just 2 has to be brought in front. Sin x by 1 plus cos x whole square. So this 1 plus cos x will directly give us the sin x. So there is no problem as such in this question. T equals to 1 plus cos x. Dt by dx will be 1 will be 0. Cos x will be minus sin x. So negative will come here. Negative dt will be equal to sin x dx. So this numerator sin x dx will be negative dt. So integration will be negative will come in front, dt divided by 1 plus cos x will be t. So this will be t square. So this 1 by t square, t goes up, t raised minus 2. And integration of t raised minus 2 is t raised minus 2 plus 1 divided by negative 2 plus 1. It will be t raised negative 1 divided by negative 1. So negative will go up. So minus 1 by t will be the final result. Negative 1 by t plus constant of integration. This t is 1 plus cos x. So this will become negative 1 by 1 plus cos x. And this was minus. Minus was already there in front. So negative will become positive. So 1 by 1 plus cos x plus constant of integration, that is the final result. So this is the answer of this question in the printed form. This is the way you are going to write when you are solving it. Next, integration of cot x into log sin x. So log sin x will directly give you cot x. So we'll take t as log sin x. Dt by dx will become, this will come in the denominator sin x, and sin x will be cos x. So this will be cot x. Dt will be cot x into dx. numerator, if you see here cot x and dx, this will be dt. So we have integration like this, dt log sin x will be simple t, so it will be t square by 2, simple integration plus constant of integration. T was log sin x, so log, you can just write it inside the modulus, log modulus sin x, and this is whole squared, and of course with the 2 in the denominator, this half also you can place. So this is the way, just two-step answer. In this question, there is one just thing, that if you take log sec x plus 10x, can we get this sec x or sec x dx? When we'll take this as t, you'll see yes, of course we can get it. So t will be equal to log sec x plus 10x, dt by dx will be log of content will be 1 by that content sec x plus tan x. Now differentiation of this sec x plus tan x. So sec x will be sec x tan x will be sec square x. And now what is the benefit? When you take this sec x outside of the numerator, it will be tan x plus sec x. So sec x tan x you have taken outside. Sec x plus tan x goes into the denominator. This gets cancelled out. Dt by dx or dt will be equal to sec x dx. So t, when you placed log sec x plus tan x dt, is sec x dx, whole of this you have got. The integration will be simply, this log sec x tan x will be t, and this sec x dx will be dt. This will be simply t square by 2 plus constant of integration. What is t? T was log sec x plus tan x. Please write it inside the modulus, that will be better. Log sec x plus tan x, and then you can take any brackets and then square it. Rather than dividing it by 2, place a half in front. That will be better to write and it looks good also. So this is the result I was talking about. So this only log sec x plus tan x, if you place it as t, you will get the result. So on the basis of the previous question, if this log cosec x minus cot x can be seen, so we can solve it like that. If you place this as t, cosec x dx can be achieved. So this log cosec x minus cot x, I am asking you to place it as t. So dt by dx will be log of content will be 1 by that content. So 1 by cosec x minus cot x, and then the differentiation of cosec x minus cot x. It will be minus cosec square x, cot x is minus cosec x cot x. This cosec x will be cosec x cot x, and cot x will be minus cosec square x. So minus minus will become positive. So this cosec square x you can bring in front, minus cosec x cot x you can take out in the second, as the second term. Then you can take cosec x common from the numerator. So cosec x, whenever you take common, this cosec x minus cot x in the numerator, cosec x minus cot x in the denominator, you can just cancel this out. Cosec x and along with dx will form a dt. Now this cosec x dx is actually what we got after placing t equal to log cosec x minus cot x. So what you can write it is dt in place of cosec x dx, and just t, so t square by 2 plus c is the simple integration. T was log cosec x minus cot x. Don't forget to put it inside the modulus sign. So log cosec x minus cot x, and take a bigger bracket and then square it. Half will be outside and plus constant of integration. This is your result. So this is how you are going to write. Better way to write this one. Next is x cube cos x raised 4. Now you directly know here x to the power 4 can give you x to the power 3. So if you place t equals to x to the power 4, dt by dx will be 4x cube. So dt will be 4x cube dx. This 4 is in the denominator. So x cube dx is already there here. See, it's already there. So integration will be dt, then x cube dx is dt. 1 by 4 will come here because dt by 4 it is. Cos x to the power 4, so it will be cos just t. Got t directly, you can get sine t. 1 by 4 is already there plus constant of integration. One more thing is remaining, t can be replaced by x raised 4, x to the power 4. So 1 by 4 sine x to the power 4 plus constant of integration is your final result. So this is how we are going to write it. All this let and the symbols have to be written. Now when you take this sine inverse x square, you are going to get this x into dx by under root 1 minus x to the power 4 directly. That is, if you just place t equals to sine inverse x square, dt by dx will give you sine inverse x square will be 1 by under root 1 minus this x to the power square of that thing. So x raised 4, and differentiation of x square will be 2x. So this dt by dx, or you can say just dt, will be equal to 2x divided by under root 1 minus x raised 4 into dx. So x dx will be there, under root 1 minus x to the power 4. This whole you are going to get x dx divided by under root 1 minus x raised 4. So this t or integration will be in form of t will be 1 by 2 because this dt by 2. 1 by 2 you can take outside, dt will remain here, and then we have this t. So it will be t square, this 2 is already there, so t square by 4, 2 was already there, plus constant of integration. Now what is t sin inverse x square? You can just square it, divided by 4 plus constant of integration is your result. So this is how you are going to write. I hope you have a better idea about this question now. So x raised 4 plus 1, if directly written as t, x cube dx will directly come. Don't just put x raised 4 as t. Always take 1 plus x raised 4 plus t. So dt by dx will give you 4x to the power 3. This dt will be equal to dx you can take on the right hand side, and 4 in the denominator. Dt by 4 is x cube into dx. So x cube into dx is dt by 4, integration will become this dt by 4, write dt 1 by 4 here, and sine this sine x raised 4 plus 1, x raised 4 plus 1 was t, this will form sine t. Now integration of sine t is minus cos t. So minus cos t, in place of t I can directly write 1 plus x raised 4 plus constant of integration. That's your result. So this is the result. X raised 4 plus 1 has to be taken as t, not only x4. Please remember that thing. Now if you take this x e raised x and take it as t and differentiate, you will get this x plus 1 into e raised x. How? Now just see here. I am placing t equals to x raised x e raised x. We will apply the product formula while differentiating. Dt by dx will be x e raised x plus e raised x, and differentiation of x will be 1. We can take this ex outside, it will be x plus 1. So this dx gone on the right hand side, dt will be there. So whole this one is dt only. So this will be integration of dt. Integration will be like this. Cos square x ex. X was taken as t. So 1 by cos square is sec square. So sec square in place of x ex write t. So sec square t integration is tan t plus constant of integration. Tan in place of t x e raised x plus constant of integration. This is your final result. So this is the result I was talking about. Now it's very clear in this question that x cube will give you x square and e raised x cube will give you e raised x cube. So from here we'll take this t as e raised x cube. So this dt by dx will be e of something will be e of that thing only, ex cube. Differentiation of x cube will be 3x square. So what is the benefit? This x square, ex cube, and then the dx, this one. So this is all we can get as dt. So this integration will be, let's bring dx here, and there will be 3 on the denominator with dt. It will be dt by 3, and all other things on the right, e raised x cube x square dx. So only cos t will remain. Dt by 3 you can write like this, and cos anything will have a direct integration. This is cos t. So this cos t integration will be sin t. 1 by 3 is already there, plus constant of integration. So the final result will be like this. 1 by 3 sin ex cube. Now keep it in the bracket and then add a constant of integration. So this is your final result. Now this is the way you have to do. Please remember, e raised x cube will give you directly the other results. Here we have x square plus 3 and sec cube. So this x square plus 3 will definitely give you 2x. So we have it. But what to put tan as t or sec as t? Because tan will give you sec square. So one sec has to be separated out. So what we'll do here is sec cube can be written as sec square x square plus 3 and then sec x square plus 3. That is how we have written sec cube. And what about this 10 x square plus 3? And all other things you can write it here, 2x dx. Now why it has been done? Because when we write sec x square plus 3 as t, we'll get dt by dx as sec x tan x. That is the differentiation. So sec x square plus 3, 10 x square plus 3, and then the differentiation of x square plus 3 will give you 2x. So this dx will go on the right. So this dt, all of these content will be dt. So this is 2x, sec square you already have. We'll not deal with that right now, but all of this is going to be dt. And since we have taken sec x square plus 3 as t, so directly t square will come, because sec square x square plus 3 is already there with us. So t square dt, it will be t 2 plus 1 divided by 2 plus 1 t cube by 3 plus constant of integration. This t is sec x square plus 3, and you have to cube it. So it will be sec cube x square plus 3, 1 by 3 will come here, plus constant of integration. That will be a final result. Now how to write it is again important. So for that you can follow this scheme which is shown here. Just one thing is, sec cube will be written as sec and sec square. Now x plus 1 divided by x and x plus log x whole square. Now x plus log x will directly give you x plus 1 by x. That you already know, we have done this question in the previous exercises. So we'll take this t as x plus log x, dt by dx will be, x will be 1, log x will be 1 by x. So when you resolve this, it will be x plus 1 divided by x, and this dx will go on the right, dt will remain like this, this whole will be dt, and x plus log x will be t square. So let me write it here. It will be dt in place of x plus 1 by x into dx, and then x plus log x will be t square. This will be t raised 2 plus 1 divided by 2 plus 1, so t cube by 3 plus c. So in place of t you can write x plus log x whole cube, and 1 by 3 already there, plus constant of integration. So this is how you are going to write it. So this is the way to write, because all these English, let, now, all these have to be done. X plus log x will directly give you 1 plus 1 by x. Next we have 10x, sec square x, 1 minus 10 square x. So if you take this, when you put this 10x as a t, this 10x will give you sec x tan x. So let's see what do we get. We will try to take this t equals to 10x. Now what is the benefit? Dt by dx will be sec square x dx. This dx will go on the right hand side, so this sec square x dx we already got. 10x was t, so this integration will become this t. Sec square dx, already dt is there. Under root 1 minus 10 square x will be under root 1 minus t square. So again, solving this will again be some effort. But you know, t square differentiation will be t or 2t. So we'll take t square as some y or some k or some p. So this is the double letting we are doing. So now this dp by dt will be equal to 2t, dp by 2 will be t dt. So this t dt is going to be equal to dp by 2, and under root 1 minus t square will be p. So it's the, letting or assuming in two levels. So dp will be here, 1 by 2 will go here, dp by 2 actually, and under root 1 minus t square you can write just right. So there is a catch here. See, if we even take 1 minus t square as say p, that will reduce our effort. So here is a slight change. Rather than having 1 minus t square equals to p, I place t square equals to p. That will even complicate our issue. So now I'm showing side by side what was the error and how I'm trying to mitigate it. So dp by dt equals to minus 2t. I have taken 1 minus t square equals to p. Minus dp by 2 will be t dt. So this is negative dp by 2. dp is already there. 2 we have already written. Just negative sign has to be kept here. Negative half. Now t dt is already say negative dp by 2. But under root 1 minus t square is now under root p. Under root p. So we need to integrate the under root p. And under root p is some cp to the power half. When you integrate it, it will be p raised half plus 1 divided by half plus 1. So it will be p raised 3 by 2 divided by 3 by 2. This 2 by 3 will come when it goes up. So 2 by 3 into negative half, 2 gets cancelled, it will be negative 1 by 3. And this, I am writing it directly. It's p raised 3 by 2. And what is p? P was t square, remember? So we will replace it by this negative 1 by 3. P was t square. So 1 minus t square was p. It's not p, t square. Previously I told you can write it as t square, but it has to be written as 1 minus t square. That was the mistake I committed. So 1 minus, now t is 10x, so 1 minus 10 square x to the power 3 by 2 plus constant of integration. This is the final result. So this is a wrong technique which I showed you on the left. 1 minus t square equals to p will make all your life easier when you solve this kind of questions if it ever comes in your examination. Now this result, when you put this t square equals to p, then this is the result which I actually not solved. I explained you the other solution. This is another solution, but the answer will remain same. Next one is log x. We have sine 1 plus log x whole square we have, and x is in the denominator. So 1 plus log x whole square, if you take it as t, let's see what do we get. T equals to, this will be 1 plus log x whole square. Now when we differentiate this is dt by dx. 1 will be 0, log x whole square will be 2 log x. And the differentiation of log x will be 1 by x. So log x by x we have got. That's what we wanted. And dx, log x is already there in the question. So all of these, if we equate, it is dt by 2. So when we have this dt by 2, integration will be half, you can take it outside, and dt. This I will become integration of dt, half you can take it outside, sine 1 plus log x whole square. So sine t it is. So integration of sine t you already know. It's negative cos t, half is already there, plus constant of integration. T is 1 plus log x whole square. Now replace this t by 1 plus log x whole square. So this is 1 plus log x whole square plus constant of integration, negative half will remain like this. Now this is the way you are going to solve it. And if you just take this 1 plus log x whole square equals to t, all other things you know already. Now differentiation of 1 by x is directly negative 1 by x square, that you already know. So it's very easy to put this 1 by x as t. The differentiation dt by dx is going to be negative 1 by x square. Negative you can take on the left, dx you can take on the right. So negative dt is equal to dx by negative dx by x square, negative goes on the left. So it is dx by x square. So this integration is going to become like this. Negative goes out, dt remains here. It's cos square 1 by x, which is cos square t. Now cos square has a direct solution. That is, cos square t can be directly solved. But we need to use the trigonometric identity here. So this cos square t or cos square theta is 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. So we'll deal the negative later. 1 plus cos 2 theta by 2 can be written. So 1 by 2 plus cos 2 theta by 2. That's what you have to write. And since it is t, we'll integrate them separately. Negative you can just put it here. Negative half is outside. I'm taking this half which is common in both the terms. I'm taking outside. Negative was already there. So negative half is outside. Integration of dt is t. Integration of cos 2t will be what? It's sine 2t. But we have to differentiate 2t and keep it in the denominator. So the differentiation of 2t will be 2 and it comes in the denominator. Plus constant of integration. Now what you have to do? You have to multiply everything by negative half. T will be replaced by 1 by x wherever it is. So sine 2 into 1 by x. So sine 2 by x you can write. This 2 is in the denominator, but still negative half is already there. So when you multiply this by negative half, this will become minus 1 by 2x. This will be negative 1 by 4 sine 2 by x. And this negative half into c will again become a constant because it's a constant only. So this will be the final result. This is the result I was talking about. 1 by x and then cos square t has to be written as 1 plus cos 2t by t. Now this will be sec 4x, 10x. Now this sec to the power 4 can be, it can be kept as sec 4 into two parts, sec square and sec square. Or you can do one thing. There is a different way of doing it. Integration will be sec square x into sec square as I was talking about. And then we have this 10x into dx. Now this sec square x is 1 plus 10 square x. Now once you get 1 plus 10 square x, you already have a 10x. Now you can take this 10x and keep it as t so that you can get the middle sec square x. So what I am suggesting is t equals to 10x we can write. dt by dx is going to be sec square x. dt will be sec square x dx. So this sec square x dx is dt. This whole is dt. And wherever tan is there, just put t over there. So t 1 plus t square. See, simple algebra now you have to do. Integration will be t, I am multiplying and writing t dt plus t square into t will be t cube. So t cube dt it will be. So this is going to be t square by 2 plus t raised 4 by 4 plus constant of integration. And t was earlier 10x. So 10x whole square by 2 plus 10x to the power 4 by 4 plus constant of integration. That's your final result. So this is the way of doing it. If you can separate this raise 4 power to 2 and 2 power, then this will become very easy, because ultimately sec square x will be 1 plus tan square x. Now this is a piece of cake for you. You know why? Because e root x is already getting, we have, and differentiation of root x is 1 by 2 root x. So all the content which we want is readily available. So we can just place t equals to e root x, dt by dx will be equal to, this will remain same, e raised root x, and root x will be 1 by twice root x. Dx will go here, 2 will go this side. So 2 dt is e root x by root x into dx. That means this one, and this one is already there, which is 2 dt. Now direct integration will be there. 2 you can take outside, dt will be there. That will be cos t, because it's cos inside e root x, which is cos t. What is the integration? Cos t is sin t, 2 will remain there. In place of t, write e root x. So 2 sin e root x plus constant of integration. That's your final result. Now how are we going to write it? It's in front of you. You can try it yourself also. Now in this question, we have sine and cos. So cos can give you sine, sine can give you cos. But if you take cos x as say t, you will get sine x, that is in the denominator. So that's a problem. But if you take sine x, you'll get a cos x, but there is cos raised 5x. So one cos x can be managed. What about the other cos raised 4x? So we'll do some separation here. We will write this as cos raised 4x into cos x. So 4 and 1, it will form cos raised 5x. In the denominator, it will be sin x, integration sine, and then dx. So when you take sin x as t, you are going to get this as cos x dx. But still we have this cos raised 4x. What to do with that? Since we are taking sin x as t, we'll take this cos raised 4x, try to change it in terms of sin x, because you know cos raised 4x can be written as cos square x into cos square x. This cos square x can be written as 1 minus sin square x, and the other cos square x can also be written as 1 minus sin square x. So 1 minus sin square x into 1 minus sin square x, that is 1 minus sin square x whole square. So this is whole square power. So 1 minus t square it will form. Now 1 minus t square, that is you have to open it. That I'll show you just now. We'll do it separately, but because I want to keep the things clean on the left. So when we take t equals to sin x, dt by dx is going to be cos x, and dt will be equal to cos x dx. This whole is dt only. In the denominator, you are going to get this sin x, which is t. The numerator is 1 minus sin square x whole square, that is 1 minus t square whole square, and that is this is only a minus b whole square. So we'll open it, a square plus b square minus 2ab. So 1 square plus t square whole square minus 2 into 1 into t square. So this will form 1 plus t raised 4 minus 2 into t square. There is t in the denominator, so let's put this t in the denominator. 1 by t will directly give you log. So we don't have to do anything with that. So let us separate them out and then integrate. 1 by t dt. This 1 will get cancelled out, 1 power. So it will be t raised cube with dt. And here 1t will go and 2 will come out, and that will be a d dx. Oh, sorry, t dt. So this will be log modulus of t, plus this will be t raised 4 by 4. This is going to be t square by 2 plus constant of integration. Now let's change this t to sin x, that is the final replacement, because t we have included ourselves, so we need to get rid of it also. So log modulus sin x plus sin raised 4x by 4 minus sin square x plus constant of integration. This is your answer. So this is how you can do this. Whole idea is all about trying to find out what can give you what, how can we combine dx with certain terms, and how can we convert the t which we have taken into other content which is in the integration inside sine. This is very straightforward. We have already done a question like this, because root x differentiation is 1 by 2 root x, that you already know. T is equal to under root x. So dt by dx is going to be 1 by twice of under root x. This is dx by twice of under root x. So this 2 will go here. 2 dt will be equal to dx by under root x. This dx by under root x is already 2 dt with us now. So we can change this like this. Sin t, we don't have any denominator because dx by under root x is already we have formed as this one. 2 dt, 2 I'm taking outside. So it will be minus 2 sine t will be cos t plus c, because sine t integration is minus cos t. So let us replace t by under root x. Minus 2 cos under root x plus c is your final result. You can take a reference here if you want to solve it by yourself. This is the way it should be written. Now we have already done a question like this. Those who are following me for past 47 questions, they are aware that this question has already been done. So let's, because x into e raise x will definitely give you x plus 1 e raise x. Let's try it. T equals to x into e raise x. And let's differentiate it now. So this is dt by dx. This is going to be x. E raise x will be e raise x plus e raise x. Differentiation of x will be 1. So e raise x we can take common. X plus 1 dx. dt is this one. So this whole numerator we got. Numerator is dt and denominator is sine squared t. And a good thing is that sine squared t, when it goes to the numerator, it will be cosec squared t. And this cosec squared t is going to give you the direct result minus cot t plus constant of integration. T was x into e raise x. So minus cot t x e raise x plus constant of integration. So this is the result. Those who have already done the previous question, they can just go ahead, because this is the way they already know to solve this question. This question seems to be kind of typical at first glance, but it is not, because x plus tan inverse x is directly going to give you x square plus 2 by x square plus 1. As you have known it now, it's easier to you. So tan inverse x will give you x square plus 1 in the denominator. But this x plus tan inverse x, when it will be differentiated, you will see that whole thing which I just talked about will be there. So t will be equal to x plus tan inverse x. dt by dx will be 1 plus 1 by 1 plus x square. When we take the LCM, 1 into 1 plus x square into 1, write it here. 1 into 1, write it here. 1 into 1 plus x square, write it here. So this is x square plus 2 divided by x square plus 1. So this gives you dt, which is equal to whole content on the right. There is one more thing here that will come just now. Let's first do this thing. So you have I equals to 5 raised to the power t, because t is actually x plus tan inverse x. The whole content on the right hand side we already got as dt. The integration of a raise x will be a raise x divided by log base ea. Now 5 to the power t integration will be, just assume a as 5, x as t, and write the same thing which I have written in the formula. So let me just write it. 5 raised t divided by log base e5 plus constant of integration. T is what? T was x plus tan inverse x, if you remember. So 5 raised x plus tan inverse x divided by log 5 ln also you can write, or log e, it's up to you, plus constant of integration. This is your final result. So this is the way you're going to solve it and write it, because logic is something different, but writing is altogether different art. E raise m sine inverse x divided by under root 1 minus x square. Now here there are two things. Either you can write or assume sine inverse x as t, or you can take m sine inverse x as t. Both ways it's possible. So t is sine inverse x, dt by dx will be 1 by under root 1 minus x square. Now dx goes up, this whole is your dt. Now this is one aspect. But what is my use if you know already this can be done, right? So I will advise you not to take t as sine inverse, rather take m sine inverse as t. You will be saving one step. How? T equals to m sine inverse as x you take. When you differentiate it, dt by dx will give you what? M remains like this. It's a say non-reactive element in this mathematics if it is a constant. So m can go anywhere. Let's bring it down on the left hand side. But dx by under root 1 minus x square is dt by m. So e raised t dt, m goes in the denominator. We are taking it outside because it is a constant already. Integration of e raised t will be e raised t only. Integration of e raised x is e raised x. So e raised t, just replace t by sine inverse x now. M is already there in the denominator. So final version is e raised m sine inverse x by m plus constant of integration. Now I solved it like this. I'll show you the solution or the reference in a different way. Now let's see here. Here t was taken as sine inverse x. So there is one just step which was increased. Cos root x by root x. So this root x, when you put it as t, you will get 1 by 2 root x as the term which we already seen. A question like this. So just see the reference and go ahead. Now tan inverse x direct differentiation is 1 by 1 plus x square, dx by 1 plus x square. So t, if you take it as tan inverse x, dt by dx is going to be 1 by 1 plus x square into dx. So dt is dx by 1 by 1 plus x square, and this is already with you now because whole one part of this question is dt. Sin t, because tan inverse x was t, sin t dt it will be formed. And it's directly sin t is negative cos t plus constant of integration. So minus cos tan inverse x, because I'm replacing t by tan inverse x now. This is your final solution. Okay, this is a very straightforward way, and this is how you're going to put it on paper, write it. Sin log x, log x will give us directly 1 by x. So dx by x is in our hand now. So there is no catch here. You can just go forward with it. dt by dx is 1 by x, dx goes on the right, dt is equal to dx by x. This whole is dx by x. So you get what? Sin log x will be t, so sin t, this dx by x is dt. So sin t dt. What is this? Minus cos t plus constant of integration. T you can write it as log x, so minus cos log x plus constant of integration. Okay, this is the way you can write it. It's a very straightforward question. There is no catch here. So this is a repeated question. We have already done a question like this. Just go ahead. There are various questions which are repeated. Those questions which are important are always repeated. So just try to learn it and do it. Alright, this question is somewhat different. And previous exercises we have done this question. But since it is fresh in terms of integration, x square can give us x dx. So that's what is the first hint. X square is t, dt by dx will give you 2x. 2 will go in the denominator, dx will go up. So x dx is dt by 2. So you can use this now. X dx is dt by 2, 2 can go in front. In the denominator now this becomes t, x square is already t, so t plus a square plus t minus a square. So still we are stuck now. We cannot integrate it directly. But whenever you have root and with a plus, and these root terms are almost similar, the only thing is to get rid of this root is multiplication through a conjugate, or in different terms, rationalizing the denominator. So let's multiply the same term, all thing will remain same, only a plus will change into a negative. So I'm writing the same term, picking up the same term from the denominator, and then just placing a negative in between. And what is the term? This is just to get rid of the root. A plus b into a minus b is what? It's a squared minus b squared. So when you do this a square minus b square, you'll get t plus a square minus t minus a square. What is in the numerator? See, t plus a square minus t minus a square is in the numerator. Denominator will give you t plus a square, and you subtract this now. Because a square basically under root t plus a square whole square is t plus a square only. And t minus a square will be under root, you can just get rid of. So t plus a square minus t plus a square, tt gets cancelled, you get 2a square. So this 2a square will go in front. So 2a square is a constant, 1 by 2 is a constant. When it gets multiplied, you will get 1 by 4a square. We are going to deal with this later. Let's concentrate on the numerator now. I'm just including 1 by 4a square later on. Let us integrate this now. See, it's just x plus some constant. So don't worry about this a square or something, it's just a constant. So x plus a, x plus 1, all these are same as t plus a square. Assume this t as x. So this x plus 1, x plus a, all these things, when you integrate it, t plus a square to the power half, t minus a square to the power half. So when you integrate this is going to be, that's not 2, that's half actually. I miswritten it. This will be t plus a square to the power half plus 1 divided by half plus 1 minus integration of this t minus a square to the power half will give you t minus a square to the power half plus 1 divided by half plus 1. 1 by 2 plus 1 is 3 by 2. When it goes out, it will be 2 by 3. What is in the numerator? T plus a square to the power 3 by 2. T minus a square to the power 3 by 2. This 2 by 3, when it gets multiplied with 1 by 4a square, 2 gets 2, 1 by 2 square into 3 is 1 by 6a square. This 1 by 6a square will be here, and this whole inside is going to be x square plus a square to the power 3 by 2, because I'm replacing t by x square now. X square minus a square to the power 3 by 2 plus constant of integration, of course. So this whole is your final result. This question has more algebra than the integration, because if you understand the integration part, algebra you have done since you gain senses. So this is the solution I was talking about, okay? And you can follow this routine so that you can write it in the way it's being shown here. Now this 10 inverse x square will give you 2x, and 10 inverse x square will give you 1 by 1 plus x to the power 4. It's a straightforward question now. T is 10 inverse x square, dt by dx will give you 1 by 1 plus x square whole square, so 1 plus x to the power 4, and dx goes on the right. But there is one more thing still remaining, which is x square. So x square differentiation will be 2x. So dt is equal to 2x by 1 plus x to the power 4 dx, and this 2 we can take on the left hand side. So this will become what? X dx by 1 plus x to the power 4 is dt by 2. So this integration will become, this is 1 by 2 integration dt, and what do you get? 10 inverse. This is 10 inverse x square is already t, so it's just t square by 2. So t square by 4 it will be, 1 by 2 is already there with us. So let's do it. T square by 4 plus constant of integration t, you can just replace it by 10 inverse x square, and this whole square is there. So 10 inverse x square whole square. Please, it's x square, okay? Please remember. Okay, this is all about how to write it, and this question is a good question, I must say that. Sine inverse x whole cube and divided by under root 1 minus x square. Sine inverse x differentiation will directly give us 1 by under root 1 minus x square. There is no catch in this question. So just assume t equals to sine inverse x, differentiate it, you will get 1 by under root 1 minus x square. Dx goes on the right hand side. So this whole is dt. And how about the sine inverse x? It was already taken as t. So this will be t cube, and this dx by under root 1 minus x square will be dt. So this will be t raised power 4 by 4, x to the power n plus 1 by n plus 1 formula I have used, plus constant of integration. In place of t, just write sine inverse x to the power 4 divided by 4 plus constant of integration. That's your final result. Now this is a very straightforward question. You can just try it by yourself also. Now log x. Log x differentiation is always 1 by x, that we have known. But my logic is that whenever you have a constant around this log x or any term, take all the term as t. That is, t equals to log x is not that better than 2 plus 3 log x. So when we differentiate it, 2 will go, and we'll just be having 3 by x dx. So dt by 3, this becomes dx by x, and dx by x is already with us. So just write it as dt by 3. So integration will become like this. 1 by 3 I'm taking out, which we have just got below dt, and then we have sine t, because t is 2 plus 3 log x. What is the integration of sine x? It's negative cos t. Let me write it t as 2 plus 3 log x. So it will be 2 plus 3 log x, and this is negative 1 by 3 plus constant of integration. So this is how you are going to write. Please don't forget to write this let, now, and all the symbols. This is a question being repeated. If you put x square as t, you will get 2x. So this is question which I have already formally discussed. So just have a look at the solution or the reference. E raise x. Now e raise 2x divided by 1 plus e raise x. So if you have already done this question, let me tell you, you might have done like this: e raise x into e raise x. E raise 2x can be written like this. So this t is equal to e raise x, dt by dx will be equal to e raise x when we differentiate it. There is nothing with x, so it will be just e raise x. Dx goes on the right, dt will be e raise x dx. So integration will become like this. E raise 2x we have written as e raise x, dx was already there, so e raise x dx is dt. Altogether it's dt. So we have e raise x in the numerator, 1 plus e raise x in the denominator. So numerator e raise x is t only. This is t and this is 1 plus t. Now this is the catch. So always I encourage you not to take just e raise x or anything with 1 or a constant. So I'm now taking a different step, different route rather. 1 plus ex equals to t. So dt by dx will be equal to e raise x. See how easy it has become now. Dt was in earlier assumption also e raise x dx, here also. But here t by 1 plus t denominator will be difficult to handle. And in order to make it much more easier for integration, the step I'm just crossing it right now. The right step or right way is e raise x dx. This is dt. Now e raise x divided by 1 plus e raise x. 1 plus e raise x is t. So it is in the denominator. E raise x from here. 1 plus e raise x equals to t. So e raise x will be equal to t minus 1. So this is t minus 1 divided by t. And the integration of this term or their two terms will be quite easier. T by t dt minus 1 by t dt. T by t cancels out. You will get a dt. Integration of dt is going to be only t minus log of modulus t plus constant of integration. And t was taken as 1 plus e raise x. Please remember, we dropped the idea of taking e raise x equals to t. T equals to 1 plus e raise x. 1 plus e raise x minus log modulus of this t, for which t I am writing as 1 plus e raise x plus constant of integration. Now most of the students will stop here. But those who have practiced, they know there is one more catch in this question. See, if you say 2 is a constant, 2 plus 3, 5 is a constant. So anything added with a constant will constant only. So we have a 1 in front. Constant plus 1 will be again becoming a constant. You can write it in the capital letters. You can write it as a c prime. It's up to you. So c plus 1, this is again a constant. I'm writing it as a c prime now. Other terms remain the same. E raise x, this, and then minus log 1 plus e raise x plus constant of integration. You can make it x capital or prime. So you have known the difference. Two path or two route I showed you. Whichever you like, you can follow it. But the latter one will be more beneficial as far as the solving of question in no time is required. One more catch is c plus 1, because 1 was already there. Don't leave it. Whenever it is a constant with a plus or a minus, add it with c and forget about that. Now this, I think we might have done multiple questions in the similar lines, similar terms. So when we take t equals to under root x, dt by dx will be 1 by twice root x. Okay, you already know that. So dt, 2dt will become dx by root x. So this dx by root x is twice of dt. So integration will become like this. Sec square root x was t, and this dx by under root x will whole become twice of dt. So this sec square integration, we have a direct integration. Tan, simple tan. Okay, so tan t, 2 was already there, constant of integration. What was t? Under root x. So 2 tan under root x plus constant of integration is your final answer. So this is the reference for you. Tan cube 2x sec 2x dx. Now just think what we are going to put so that we can get the other part of this integral in an easy way as an assumption. So tan cube 2x is there. You know that tan square has a relationship with sec x. When we differentiate sec x, you'll get sec x tan x. So 1 tan x you can take apart and keep it with sec 2x and tan 2x. Tan cube 2x can be written as tan square 2x into tan 2x into sec 2x. Alright. So tan square 2x, this one. This is sec 2x, sec 2x and tan 2x. Okay, let's integrate this now. We have this dx. Okay. Sec x differentiation is sec x tan x. So when you put this t equals to sec 2x, dt by dx will be equal to sec x, sec 2x, tan 2x. Okay, one more thing is 2x will be differentiated and it will be 2 in the denominator. I have not written it, but I'll include it in later part. Okay, I have not written it. It's just don't think that I have forgotten it. I'll use it in the later part. Okay, so sec x tan x will be equal to dt by dx. But your question will be, if you take sec x tan 2x dx as dt, then how you can write sec 2x? We can write, because you already taken sec 2x with tan 2x. So this tan squared 2x can be written as sec squared 2x minus 1. You know already the formula. Sec 2x tan 2x dx will be dt. So dt will be sec 2x tan 2x and dx. This whole is going to be dt. So this whole from here to here, it's dt. So sec squared 2x minus 1 will be t square minus 1 dt. So when we integrate it, there is 2 also. Please remember, I've just not written it. We'll include it. 2. So t square minus 1. So this is the whole idea. Now this will be t square integration separately and minus this dt integration separately. It will be t square plus 1 by 2 plus 1, so t cube by 3 minus this only t plus constant of integration. T is a sec, if you remember, it was sec 2x cube. And where does this 3 combine with the dt by 2? I told you I will include this 2. So it will be 1 by 6 actually. And then t will also be, as I said, 2x will be differentiated. That 2 will come here. What is the differentiation of the replacement of t? It's sec 2x. So this is 1 by 2, 1 by 2, 1 by 2. Let us include this now. And this half multiplied by 3 is going to be 1 by 6. This will give you half sec 2x plus constant of integration. So the final answer, you must have a look, and this will be 1 by 6 sec cube 2x minus sec 2x divided by 2 plus constant of integration. Okay, this is how you are going to write it. It's very important to write rather than understanding is one thing and writing is another thing. Now this is x plus under root x plus 1 divided by x plus 2. So we have to first get rid of this under root. First thing is this one. Then only we'll be able to integrate it properly. So t will write it as under root x plus 1. T square will be equal to x plus 1. And when we differentiate it, because we will be needing x, so you can write x as t square minus 1. When we differentiate t square equals to x plus 1, it will be 2t dt by dx. dt by dx equals to, this differentiation will be 1. Now what will be dx? It will be 2t dt. Now come here. So now this integration is going to become like this. This dx will be replaced by 2t dt. In place of x, you can write t square minus 1. This under root x plus 1 was t. And denominator x plus 2. Now you can just add 2 here. X plus 2 will be equal to t square minus 1 plus 2. So it will be t square plus 1. So t square plus 1 in the denominator. So now multiply the numerator all along. This 2 will take later. So it will be t cube minus t, and plus t into t is t square divided by t square plus 1. Now we have to do something so that we can get rid of t square plus 1, or we can add or subtract something so that we can differentiate t square plus 1 and get something in the numerator. So I am adding a t and subtracting a t. So there is already a negative t. Okay. Then this, what to do with t square? Let's add 1 and subtract 1. In the denominator you will have t square plus 1. So t cube plus t by t square plus 1, one thing. This t square plus 1 I am bringing it in the front. T square plus 1 divided by t square plus 1. Then we have negative 2t minus 1 divided by t square plus 1. When you take t common from here, you will get t square plus 1. In the denominator, it is t square plus 1. This gets cancelled. So you can just have a dt. Please remember, integration in dt is already everywhere. I'm not writing it. That doesn't mean you will not write it. So it will be, this is negative 2t plus 1 by t square plus 1. So this gets cancelled. T dt integration will be direct. T dt integration and this dt integration. All this integration sign, don't forget, there is always a dt along with these separate terms. We'll talk about this 2t plus 1 by t square plus 1 in a bit. But integration of first term is t dt. The second one will be integration of just dt. So I'm separating this 2t plus 1 term into 2t by t square plus 1 minus 1 by t square plus 1. So this will be direct t dt. Integration. So this integration of t dt is t square by 2. dt will be t. This both we got. How about this 2t by t square plus 1? So when we write t square plus 1 equals to some p, dp by dt will be 2t. This dp by 2 will be t dt. So this t dt you can write dp by 2, and already 2 is there. One more t is 2 was there. I will use it in the later part, as I indicated to you earlier. So this 2 gets cancelled in the this part. So dp by p, if you integrate it, it will be log modulus of p. P was taken as t square plus 1. Log t square plus 1. What was t square? t square is x plus 1, so it will be log x plus 2. What I'm trying to suggest here is log t square was x plus 1, and when we assumed 1 is already there, so it will be log x plus 2 in the modulus sign. This log x plus 2. So this, let me just change it now. In terms of x, I'm writing t square is x plus 1, x plus 1 by 2. This is our first term. T is what? Under root x plus 1. So it will be under root x plus 1. And for this, we'll write minus log modulus x plus 2. Now one more term is remaining. Integration of 1 by 1 plus t square. So this integration of 1 by 1 plus x square was tan inverse x. You already know that. So this will be tan inverse t directly. 1 by 1 plus t square will be tan inverse t. And what was t? T was under root x plus 1. So I'm just adding it now while subtracting actually. Tan inverse under root x plus 1. So this whole is your final answer. Please multiply by 2. As I told you, 2 I am going to use a later part. This 2, this 2. So now just multiply everything by 2. This gets cancelled. You'll get a x plus 1. Then you have plus 2 under root x plus 1 minus 2 log modulus of x plus 2 minus 2 tan inverse under root x plus 1 plus constant of integration. Okay. So this is a solid question. It needs some practice. So you must have a look here. This is how you are going to go about it. So there are certain things which are not in this printed version. You have to go back and just understand how I did each separate part and what is the reason of having this answer. This one is more like a reasoning question. So 5x, 5x, and then dx. We have no option. We have to just take 5 raise x. So t will be equal to 5 raise x. Now a raise power x will be what? It will be a raise x will be a raise x. Integration you know already, but differentiation I'm talking about. Differentiation will be dt by dx, and a raise x differentiation is a raise x log ea. So a is 5 here. 5 raise x log 5. So dt log 5 will come in the denominator. 5 raise x will be there, and this will be dx. So this already we have. So this integration is going to be, so we'll align this with our assumption and what is given in the question. So dt by log 5. So 1 by log 5 here, and this is dt. Now 5 to the power 5x is t. 5 to the power x is t. So it will be, and whole 5 raise x dx was already dt by log 5. So 5 to the power 5x is 5 raise t. 5 to the power 5x is 5 to the power 5t. So not until now we have just reached the half part. So this is the second level of assumption. Take p equals to 5 raise t. dp by dt will be again the same formula we are going to apply. A raise x log a. A is 5 here and x is t here. So dp, one more log 5 has come in the denominator. It will be 5 raise t dt. Now you see 5 raise t dt already we have here as dp by log 5. You just got it. So one more log of 5 will come in the denominator. So let us make it as log 5 whole square. Integration, this whole we already got. It is dp by log 5. We already written it. And this log 5 already included here in the denominator. 5 raise 5t will become 5 raise p. It was taken as p. So this 5 raise p, again a raise x integration we have to do. So a raise x divided by log base ea. So 5 power p will be x is p, 5 is a. So 5 raise p by log base e5. Let us write it here. Again one more log 5 has come. So let us make it as cube log 5 whole cube that we are going to do. And this whole is going to be getting it from here. So 5 to the power p plus c. But p was what? It was 5 raise t. So let me write it here. 5 to the power p was 5 power t. And t was what? 5 raise x. So 5 to the power 5 to the power 5 raise x. So the final answer would be 5 to the power 5 to the power 5 x, and in the denominator you have log 5 and this whole cube plus constant of integration. And how you are going to go about it, it's in front of you. There will be two level of letting or assuming. 1 by x under root x to the power 4 minus 1. How are you going to get x in the denominator? X to the power 4 can be written as x square to the power whole square. That we know. X square differentiation will be 2x, but 2x is in the denominator. That means x is in the denominator. That is the problem we are facing. So what we are going to do here is, we'll make certain adjustments. What will be the adjustment? We'll multiply numerator denominator by x, and denominator under root x square whole square minus 1 will write. So this integration will become x, we have introduced by ourselves x dx. This x in the denominator will become x square. This is under root x square whole square. So x square whole square we are writing minus 1. Now let us go to our normal routine. X square equals to t, dt by dx will be equal to 2x, dt by 2, this x dx goes here. So this x dx in the numerator can be written as dt by 2. This one dt by 2. So this integration will become dt by 2. I am taking half here. This whole in terms of x square we write 1 by t under root t square minus 1. Now what do you think? Do you smell something good here? Yes, because sec inverse, if you integrate 1 by t under root t square minus 1, you will get sec inverse t. Because when you differentiate sec inverse t, you are going to get 1 by t under root 1 t square minus kind of thing. So same we are going to use here. When you integrate it, it will be directly sec inverse t. So this half, this whole has become sec inverse t plus constant of integration. Half sec inverse in place of t, write x square plus constant of integration and say it as a final answer. So this was very straightforward. If you know that x and x can be multiplied, numerator denominator, that will give you an easy result. Just x square equals to t, all will be like under root e raise x minus 1 dx. So first thing is that we need to get rid of this under root. If you have some denominator, then we'll try to put that denominator and try to get the numerator. But here there is no denominator. For that, we need to get rid of the under root. These are certain tricks which you can follow. So this t is under root ex minus 1, t square will be e raise x minus 1. And when we differentiate this, and since we have to put this e raise x also, it will be t square plus 1. So let's differentiate now. 2t dt by dx will be e raise x. Now e raise x minus 1 whole is t. So what about dx? Because you have to put dx also. So from here dx will be what? Just take dx on one side and other things on other side. Then we'll formulate the dx. It's t square is e raise x minus 1. So this e raise x will be t square plus 1. We'll put it here. Dx will be equal to 2t dt and divided by what? It's e raise x. E raise x is t square plus 1. So what is the benefit now? Integration will be, this will be t. Under root e raise x minus 1 will be t. And this whole dx will be 2t dt by t square plus 1. Let us write it. 2t dt by t square plus 1. 2 I am taking it in front of the integral sign. This will be t square, denominator will be t square plus 1 and dt will remain like that. So this is t square plus 1 now. So we'll add a 1 and subtract a 1 just to get the two terms which can be integrated easily. So this will be t square plus 1 by t square plus 1 minus 1 by t square plus 1. So this is going to be 1. We are going to deal this 2 later. This is integration of dt minus integration of t square plus 1 dt. So the direct integration is feasible here. Dt will be t. 1 by 1 plus x square is tan inverse x. So it will be tan inverse t plus constant of integration. 2 was there. So let's multiply 2 and t will replace by under root e raise x minus 1. Let's write it. 2 under root e raise x minus 1 minus 2 tan inverse under root e raise x minus 1 plus constant of integration. That's your final answer. So this is how we are going to do this. The main thing is you need to get rid of this under root. For that you have to put t square as under root e square minus 1, e raise x minus 1. And then we will try to replace dx with whatever we get when we do the differentiation. Now this question we have x plus 1 in the denominator. And the denominator we have x square plus 2x plus 1. I am taking this 2 as 1 plus 1. So x square plus 1, that is 1 square only, plus 2x we have taken 1, so we are just left with 1 only. So what do you get? X square plus 1 square plus 2x. It's x plus 1 whole square. Plus 1 is there. So what do we get? Integration will be integration of 1 by x plus 1, and this x square plus 2x plus 2 has become x plus 1 whole square plus 1. And this will be dx in the numerator. So this t is equal to x plus 1 will take it at, because dt equals to dx when we differentiate it. So this integration will be, this dx will be dt, so dt divided by x plus 1 is t, x plus 1 square is t square plus 1. But still we are lacking. Still we have to do something. So we'll take this t square as a p. So 2t will be equal to dp by dt. So how do we get? Because we have to replace dt by whatever we have on the other side. So dp will be 2t dt, or you can say dt will be dp by 2t. So this dp by 2t will be replaced in place of dt. So integration will be, this dt will become dp by twice of t, dp by twice of t. This t is already there and t square plus 1 is there with us. So what do we get? What is the benefit of taking this t square as p? This is dp and this is 2t square and t square plus 1. I'm just writing it because I just want to show you why this p was taken as t square, because p, wherever t square is there, we'll replace it by p. So this is dp, half will come outside, this is p and this is p plus 1. Now what is the benefit of this? You will ask question. Half dp, just multiply this, p square plus p. Now this p square plus p is kind of a quadratic equation without a constant. So in order to make a perfect square, whatever is in front of p, just make it half, because it is 1, so we make it half, so it will be half. Square, add and subtract, that is just square it. Square, add it and subtract it. So a square plus b square plus 2ab, it's p plus half whole square. The first three terms, p square plus p plus half square, is simply p plus half whole square. The other term is minus half square. So this is half dp, same thing I'm writing here, p plus half whole square minus half whole square. So it's a kind of x square minus a square in the denominator. So integration of this dx by x square minus a square is equal to 1 by a log x minus a by x plus a. That you already know. X is whole p plus half and a is half only. So this is going to be half. So this will come here. Please just worry about the constant, because constant is main thing which can change your result. But log p plus half, because x minus a, so p plus half is x, a is half, so p plus half minus half. In the denominator it will be p plus half minus half plus constant of integration. So this numerator will be p only. Log, half gets cancelled, it will be p only. Half plus half is 1. So this is p plus 1 plus constant of integration. Now p was t square. So log t square by t square plus 1. This is log plus constant of integration. What was t square? If you remember, if t is x plus 1, t square will be x plus 1 whole square. So you can just write it here, x plus 1 whole square divided by this x plus 1 whole square plus 1 plus constant of integration. Now you can resolve this, and x plus 1 whole square you can just take 2 in front, because log x to the power y is y log x. So log x plus 1 whole square, you can take this 2 in front that I just told you. This 2 comes in front. So let us write it here. It's 2 only. So 1, 2 initially, then we got another 2. That was done. Now we have another 2 here. So there is a 2. There is separate cancellation, which is already done. Now for this x plus 1 whole square, there is a 2 again in the picture, and in the denominator x plus 1 whole square plus 1. So x square plus 1 square plus 2x plus 1, that is x square plus 2x plus 2. That is what was originally in the question. So this is your final answer. So log x plus 1 divided by x square plus 2x plus 2 in the root. This is your final answer. So this is how we are going to do this. Don't worry about the constant, that is quite known to you. 2 and half will get cancelled. There will be half remaining. That goes to the power inside, and that will form a root. X to the power 5 divided by under root 1 plus x cube. Now x cube equals to t, you will get some x square term. So we can adjust the numerator accordingly. So x to the power 5 can be written as x cube and x square. Power gets added. If you multiply x square and x cube, you will get x to the power 5. So you have x cube and x square in the numerator with a dx. The denominator will be 1 plus x cube. This x cube, this is going to be t. X cube is t. So this dt by dx will be 3x squared. dt by 3 will be equal to x square dx. And this x square dx, we will just replace it by dt by 3. This is dt. 1 by 3 comes here. X cube is t. And 1 plus x cube. It's better to take 1 plus x cube actually. So I'm just changing the approach. I'm not taking x cube as t. I'm taking x cube plus 1 as t. The result will remain same. Only the denominator, rather than having 1 plus t, we can have under root t. Accordingly, we'll change the numerator, because t minus 1 it will be. Because numerator will be x cube. That's what we wanted to put. So this will be 1 by 3 in front. Let us separate them out. 1 by 3 will deal later. So t by under root t dt minus integration of dt by under root t. So t raised power 1, t raised power half, this goes up, 1 minus half is half only. So t raised half it will be. This will be t raised half minus t raised minus half. We'll differentiate it in terms of dt now. So t to the power half plus 1, that is 3 by 2. 3 by 2 will be in the denominator, it goes up and it will form 2 by 3. t raised minus half plus 1 will be half only. T raised half. 1 minus half is half. It will be t raised half. Denominator is negative half plus 1. Again half. So 2 goes up. So what was t? X cube plus 1 or 1 plus x cube. So 2 by 3 x cube plus 1 to the power 3 by 2 minus 2. T was 1 plus x cube. So 1 plus x cube to the power half plus constant of integration. Now I told you that 1 by 3 we will be dealing later. So 3 will be multiplied. So 2 by 9 and 2 by 3 will be formed and multiplied by c by 3. So that will be constant only. So this is how we are going to approach this question, and this is the way you can solve it. Please remember, x cube equals to t will be, it will add some effort. X cube plus 1 equals to t will be easier. Next one also, 5 minus x square equals to t, you will get x square x term. So you ought to have this x square, x cube can be changed into x square into x. 4 I have taken outside. Under root 5 minus x square. Now 5 minus x square, this you can take as t. dt by dx will be equal to, 5 will be 0, this will be minus 2x. This whole x dx, just multiply dx here and bring this negative 2 on the denominator. So x dx will be minus dt by 2. This will be 4. Let's take this 4 will deal later. Okay, x square from here will be t 5 minus t. So in place of x square, write 5 minus t. 4 for later. X dx is negative dt by 2. So minus 4 multiplied by this negative 4 will because of this negative dt by 2. So it will be negative 2 minus 4 by 2. 5 minus t under root 5 minus x square is a t. Under root t it will be. Now let's multiply. 5 under root t is t to the power half. So 5 I am taking outside. T raised half. Now multiply t with under root t. So t into t to the power half. T to the power 3 by 2. 3 by 2. This is integrated with respect to dt, and negative 2 will deal later. So what will be the integration? T raised half plus 1, that is 3 by 2. Denominator you have half plus 1, that is 3 by 2. It goes up, it will be 2 by 3. And 3 by 2 plus 1 is 5 by 2. So it will be 2 raised 5 by 2. This 5 by 2 in the denominator goes up, and 2 by 5 it will be. So this is going to be 5. And negative 2 is still there in the number negative 2. I told you that I'm going to deal it with later. So negative 20 by 3. What was t? 5 minus x square. So 5 minus x square to the power 3 by 2 minus 2 by 5. So you have to multiply it by negative 2. This will be plus 4 by 5, and in place of t, 5 minus x square to the power 5 by 2. That's constant of integration. Now this is how you are going to go about it. And this question has no catch. Just x cube can be written as x square and x, and rest things are known to you. So this question we have not done, but when after 2 step or 3 step, you will realize this kind of question we have already done. You will just see. If you take this root x outside, what are you going to get? Don't worry, just divide root x inside and then formulate what will be the denominator finally. So I am dividing root x because I have multiplied root x in the denominator. So root x will be there, root x by root x will be 1, x by root x will be what? Multiply numerator, denominator by root x. So root x will give you, this will be x get cancelled. So you have a root x. So this kind of question we have already done. I told you after 2 steps, you will realize this question already done. So 1 plus root x will be taken as t. dt by dx will be what? 1 by twice of root x. So this dx by root x we got. So this dx by root x will be dt by 2. So let us replace it. Dx by root x we will put dt by 2. So this dt goes here, half goes down. 1 plus root x was t. It's simply log t. The final integration will be, because 1 by t, dx by x is log x only. This is 2, not half. Okay, there is a slight change here. Log modulus of t plus constant of integration with 2, and t was 1 plus root x, so just change it. Log in the modulus you have to take t as 1 plus root x plus constant of integration, right? So this is the way we have to go about it. Root x if you take outside, if you know that, then other things will be quite easier. Please don't forget to put this modulus sign. Now in the previous question we have seen that if we change certain things or we reformulate the question, we'll be able to do it. Now what does it mean? 1 plus x to the power 4 to the power 3 by 4. It simply means 4th root of 1 plus x to the power 4 cube, right? So if we take x to the power 4 outside of this one in the root only, 1 by x cube, 1 plus 1 divided by x to the power 4 will come, cube will remain there. So it will be x to the power 4 into 3, that is x to the power 12. and 1 plus 1 by x to the power 1 plus 1 by x to the power 4 to the power whole 3. Now what is the benefit? Because x square is already there. This x to the power 12 fourth root, when you take 1 by 4 of x to the power 12, it is 12 by 4, that is 3. X cube will come outside. See, 4, and this is cube. So if you replace this x to the power cube whole 4 and take the fourth root, this 4 will get cancelled. Only x cube will come out from x to the power 12. That you already know. X cube comes out. So this integration will be 1 by x cube. X square was already there. X cube will come out. Let us write it as x cube. In the denominator, what do you get? X raised 4 plus 1 to the power 3 by 4. We have now changed it into 1 plus 1 by x to the power 4 to the power 3 fourth root. So it's just 3 by 4. Now what is the benefit? Now I'm taking this in the numerator. 1 plus 1 by x to the power 4 in the numerator, it's negative 3 by 4. This x square and x cube, x to the power 5 it will come. And now you realize if you take x raised 5 or 1 by x to the power 4, we can get x to the power 5. That is t equals to 1 plus 1 by x to the power 4 dt by dx will be negative 1 by x to the power 5. That's what is in the denominator. Dx by x to the power 5. We have got it's negative dt. So when we differentiate this x to the power minus 4, it goes up when. So n x to the power n minus 1. So it will be negative 4 into x to the power 5. Negative 5. So x to the power 5 will come in the denominator. So we have a negative 4 also. So what do? We just need dx by x to the power 5 on one side. So dx by x to the power 5 will culminate and will result in negative dt by 4. It will be 1 dx by x to the power 5, which is already there in the simplified form which I just told you. So let's do it here. I have less space, so just bear with me. So let's integrate now. 1 plus 1 by x to the power 4 was taken as t, so it will be taken t raised negative 3 by 4. Dx by x to the power 5 is negative dt by 4. Negative 1 by 4 I have taken out, dt remains there. Now it's just x to the power n integration. It will be t raised negative 3 by 4 plus 1 divided by negative 3 plus 4 by 1. What is 1 minus 3 by 4? It's 1 by 4. So 1 by 4 in the denominator, it goes up because negative 1 by 4 is already there. This goes up 4 by 1, so only negative will remain. Other things will vanish or they will be cancelled out. What is in the numerator? It's t to the power 1 by 4 plus constant of integration. So you have negative t raised 1 by 4. What was t? 1 plus 1 by x to the power 4 to the power 1 by 4. That is the fourth root plus constant of integration. That's your final result. So this is the way you have to go about. All sign and all symbols have to be utilized. Don't just do the way I told you. It has to be written like this. This is the very important part which you need to actually consider. Now sine raised 5x and cos raised 4x. If you take cos x equals to t, you will get a sine. And sine is in the odd power. So we are getting to the solution. Because there is no that much of simplification as we did in the previous few questions. So this sine raised of 4x into sine x is eventually sine raised 5x. Cos raised 4x, it will be cos raised 4x only. So if you put cos x equals to t, you will get sine x dx eventually. So what to do with this sine 4x? Sine square x plus cos square x equals to 1. Sine square will be equal to 1 minus cos square. So power 4 is 1 minus cos square whole square. So this sine raised 4x will be 1 minus cos square x, which is eventually equal to cos square x, sine square x, and that is whole square of that thing. So it's square. So sine x dx remains there, cos raised 4x in the denominator. Now if you want to just change them, that is, you can separate them out, that also you can do. But now I would advise you to just put this cos x equals to t right now. So dt by dx will be equal to, what is the differentiation? Cos x will give you negative sine x. So negative dt is sine x dx. So this is your sine x dx. It is negative dt. It will be integration of 1 minus cos square x will be 1 minus t square whole square. Sine x dx is negative dt. So let's just put dt and negative outside. And we have cos raised 4x. So t raised 4. So now let's open it. We will open this and then formulate certain terms which can be differentiated easily. So a square plus b square minus 2ab, 1 square plus t square whole square, that is t raised 4 minus 2 into t square. The denominator here t raised 4, here also t raised 4, same thing. So t raised minus 4, this will be 1, and when it goes up, 2 minus 4 is negative 2. So t square t raised minus 2 it will be. So we'll integrate it separately now. It will be very easy for you now. T raised minus 4 is t raised minus 4 plus 1 divided by negative 4 plus 1. This will be simply t. This is going to be minus 2. T raised minus 2 plus 1 divided by negative 2 plus 1 plus constant of integration. Now this is t raised negative 3 divided by negative 3 plus this will be t negative 2 and this will be negative 1, so I'm just changing the sign. This will be t raised minus 1 and that simply means 1 by t. So 2 by t plus constant of integration. So minus was already there in the beginning. If you remember, I told you negative will use. Just multiply everything with a negative. So t will be cos x. The final replacement will be 1 by cos x whole cube with a 3 there minus t was cos x minus 2 by cos x plus constant of integration. That's your final result. So this is the way you can do it. So I have taken cos x equals to t way earlier. So these are 72 questions we have done. I hope you have a better idea now. So thank you so much. Have a good one. This is all about this exercise.